Hi everyone, for today's lesson we are going to learn how to apply the remainder and factor theorems, which is an extension of what we learned in our last lesson on long division and synthetic division. Our learning targets for today are for you to be able to say, I can use synthetic division to factor polynomial functions and to find every zero, which represents x-intercepts, of a polynomial function. So there are two different things that we are going to be using. We're going to be using synthetic division to factor versus finding every zero means to solve quadratic equations. So to start this problem off, I would like you guys to look at this problem. We have 4x to the fourth plus 29x cubed plus 4x squared minus 14x plus 6 divided by x plus 7. Please go ahead and divide these polynomials on your own. And when you have an answer, please go ahead and restart the video and let's see how well you did. All right, so hopefully you recognized that because we're dividing by a linear binomial, that we get to use synthetic division, which everyone loves synthetic division. And that means that we are going to be working with the zero of x equals -7 to start this problem. So we're going to put -7 inside of the little box. And I need to make sure that every degree is represented. So I have a 4, 3, 2, 1, 0. So every degree is represented. And I have a 4, a 29, a 4, a -14, and a 6. I'm going to put a vertical line in between my last two numbers and a horizontal line going straight across. And I'm going to bring down the 4. And I ask myself, what is -7 times 4? That's -28. 29 minus 28 is 1. -7 times 1 is -7. 4 minus 7 is -3. -7 times -3 is positive 21. -14 plus 20. Plus 21 is equal to 7. -7 times 7 is -49. And 6 minus 49 is -43. So if we were to write down our answer, it's always going to be 1 degree less than what we started with. And since we have an x to the fourth power, a 1 degree less than x to the fourth power is x to the third. So our answer should be 4x cubed plus x squared minus 3x plus 7 plus our remainder, which is -43, over our divisor, which is x plus 7. And this is our full answer. Pretty cool. Hopefully you were able to get this answer correct and you found it to be relatively easy. So now, what happens, or what does it mean if the remainder wasn't like -43? What if it was 0? A remainder of 0. Now think about that. When we've divided before and we ended up with no remainder of 0, it ended up being like a factor. Like if we divided 40 and 8, we would get 5 with no remainder. So this means that there would be no remainder, and it divides into the polynomial evenly, making it a factor of the polynomial, which means that we can actually factor the polynomials, where we already know what one of the factors are. So that's where the factor theorem comes in. This means that if f of k is equal to 0, then x minus k is a factor of f of x, and k is a 0 of f of x. So remember that x minus k, we would be in parentheses, and it would be a factor of it. And that would mean that k is a 0, or in other words, an x-intercept of the function. So it's all connected to each other, which is really cool, and that's called the factor theorem. So the first set of directions, now I'm going to be assessing you when you guys take your quiz on directions. This first section is all about factoring. Now remember, whenever I've taught you factoring, and solving, I always teach you factoring first, and then I teach you about solving. In this first example, it says, given the polynomial f of x, and a factor of f of x. I would like you to factor f of x completely. Now, looking at this problem, it says after dividing by the given factor, factor the quotient and rewrite using all of the factors. So that is my little hint for you. So looking at this problem, notice that it has 4 terms. And if I had originally given you this problem and I had said, hey, I want you to factor it, you would say, cool, this is 4 terms, so I'm going to factor by grouping. But when you factor by grouping, look what happens. 2x cubed and 11x squared. We would factor out that x squared, leaving us with 2x minus 11. And then I would factor out the 3x and the 36. I'd factor out 3, and I would be left with x plus 12. Look at our insiders. They're not the same. So that means that factoring by grouping doesn't work. And when factoring by grouping doesn't work, what do you do in order to factor? Well, we get to use synthetic division. So I am giving you one of the factors. I'm telling you that one of the parentheses is x minus 3, and I would like you to find all of the parentheses, that factor, to give us this answer. So I am going to use 3, x equals 3, and I'm going to put it inside of the little box. And I'm going to make sure that all of my degrees are represented, 3, 2, 1, 0, they all are. And I'm going to write 2, negative 11, 3, and 36. And now I'm going to bring down the 2. And 3 times 2 is 6. Negative 11 plus 6 is negative 5. 3 times negative 5 is negative 10. 3 minus 10 is negative 7. 3 times negative 7, that is equal to, hold on, I think I might have done that wrong. Hold on just 1 second. Bring down the 2. I'm sorry, this is 15. I'm like, this isn't working out. 3 minus 15. There we go. And that's going to give me negative 12. There we go. And 3 times negative 12 is negative 36, giving me a remainder of 0, which tells me that x minus 3 is a factor. So I'm going to write down x minus 3 first. And then remember that what's below the line is going to be 1 degree less. So that's going to be 2x squared minus 5x minus 12. And I need to factor this trinomial even further. So that's going to be x minus 3 times 2 more parentheses. And I'm going to split apart the 2x squared into a 2x and an x. And I have to look at the factors of 2 and look at the factors of 12 and somehow come up with a negative 5. And if I were to think about those numbers, I would look at 2 and 1 and the factors of 12. I always think of 3 and 4 first, and then 2 and 6, and then I would work with 1 and 12 with my goal being a negative 5. So I'm going to try some things. 2 times 3 is 6. 1 times 4 is 4. 6 and a 4 can't get me a 5, so let me try a different way. 2 times 4 is 8. 1 times 3 is 3. 8 and 3 can get me a negative 5, and that's if I have 2 times negative 4 will give me a negative 8, and 1 times positive 3 will give me a positive 3, and negative 8 plus 3 is negative 5. So here is my full factorization. Cool. Let's go ahead and look at letter B. In letter B, I am telling you one of the parentheses of this 4-term polynomial is x plus 1. And I'm here to tell you that factoring by grouping is not going to work. I do encourage you to try it first, because factoring by grouping is a lot faster than what I just showed you right here. But when it doesn't work, it doesn't work. So I'm going to put negative 1 into my little box. And I'm going to write down all of the coefficients. So 1, negative 6, 5, and 12. Vertical line, horizontal line, and I'm going to do synthetic division. Bringing down the 1, negative 1 times 1 is negative 1. Negative 1 minus 1 is negative 7. Negative 1 times negative 7 is 7. 5 plus 7 is 12. Negative 1 times 12 is negative 12. 12 minus 12 is 0. Woohoo! I ended up with a remainder of 0, which is exactly what I wanted. So I'm going to write down x plus 1. It's part of my answer, But now I'm going to write down my quadratic. That's going to be x squared minus 7x plus 12, because remember this is 1 degree less than what we started with. And now I need to factor even more. I'm going to split apart the x squared into an x and an x and ask myself what two numbers multiply together to equal 12 and together add to equal negative 7, and that's going to be an x minus 3 and an x minus 4. So my full factorization is x plus 1 times x minus 3 times x minus 4. So that is all about factoring. But what if we were given a 0 instead? So I was given a factor before, and I was asked to factor. Now, if we are given a 0 of f of x, then we know the corresponding factor will divide evenly into f of x. And we can use synthetic division to find the quotient, and then we can factor. So that's what we did up here. And then if we are asked to find the zeros, we must also set each factor equal to 0 and solve to find them. So sometimes the directions ask you to factor, and sometimes the directions ask you to find the other zeros, which means that you are going to solve the equation, and you're going to use the zero product property. So in this problem, we have f of x equals x cubed plus 8x squared plus 5x minus 14, given that f of negative 2 is a 0. That means x equals negative 2 is one of our solutions. And this comes from the parentheses of x plus 2, the opposite of what we see inside. And that's going to become important a little bit later. But to start off with synthetic division, I'm going to use that negative 2. And I'm going to make sure every degree is represented, 3, 2, 1, 0. And I'm going to write 1, 8, 5, and negative 14. Always try factoring by grouping first, but I'm here to tell you it doesn't end up working out in this problem. I'm going to bring down the 1. Negative 2 times 1 is negative 2. 8 minus 2 is 6. Negative 2 times 6 is negative 12. 5 minus 12 is negative 7. Negative 2 times negative 7 is positive 14. And negative 14 plus 14 is 0. And you really do want that remainder to be 0. So I'm going to write x plus 2 because that's where the negative 2 came from. And I'm going to write down x squared plus 6x minus 7, so 1 degree less than what I started. But this time, I'm going to make it equal to 0 because I'm trying to find the zeros. So far, I have x plus 2, and now I need to break this quadratic down into 2 more parentheses. Splitting apart the x squared into an x and an x, I ask myself, what two numbers multiply together to equal negative 7, but together add to equal 6? And that's going to be a positive 7 and a negative 1. So now, all of my zeros are going to be the opposite of what I see inside. X equals negative 2, which was given to us. X equals negative 7, which is the opposite of what I see inside. And x equals 1. And these are our 3 zeros. Remember, zeros are always written as x equals a number. If I asked for x-intercepts, we would write them as ordered pairs. Let's go ahead and move on to the next page. On this next page, we have a solo question that I would like you guys to please try on your own. So in this problem, I'm asking you to find the other zeros. So I want you to take that factoring to that next level and set your factorization equal to 0 to find those other zeros. And then on top of that, I want you to use your noggin. What is another way that you could use to find the zeros for f of x if you did not already know a 0? So let's pretend as if you did not know that x equals 4 worked. What would be another way looking at that problem? All right, so now we're going to take this idea to the next level. So we've already done so many next levels, but now we're going to take it even bigger. And it says, let's take this idea to the next level. What is the value of k such that x minus 4 is a factor of x cubed minus 6x squared plus kx plus 12. Make sure that you verify your answer at the very end. Okay, so let's go ahead and really analyze what's going on with this problem. So I'm going to use synthetic substitution, and I know that from x minus 4, I would end up with x equals 4. That would be my 0, and I'm going to put 4 inside of the little box. And now I'm going to write down all of my coefficients that I see in this polynomial. 1, negative 6, k, and 12. And I'm going to do synthetic division just like I normally would. So I'm going to bring down the 1, and I have 4 times 1, which is 4. Negative 6 plus 4 is negative 2. 4 times negative 2 is negative 8. K minus 8 is k minus 8. 4 times k minus 8. Now be careful here. We're multiplying 4 times the whole product of k minus 8. So that's 4 times k, which is 4k, and 4 times minus 8, which is minus 32. So we're multiplying 4 by every term here. And now I'm going to add going straight down. 12 plus negative 32 is 4k minus 20. Now, if x minus 4 is a factor of this polynomial, what would happen here is the remainder needs to be 0. So it should equal 0 to be a factor. So what we're going to do is, in order for us to find k, we're going to set 4k minus 20 equal to 0, and we're going to solve for k. I'm going to add 20 to both sides, and we end up with 4k is equal to 20. Dividing both sides by 4, we find that k is equal to 5. Cool. Now we need to verify. And the way you verify is you do synthetic division once again. So I am going to show that 5 works. I'm going to put 4 inside of the little box, and I'm going to write 1, negative 6, 5 in the place of k, and then 12. Bringing down the 1, 1 times 4 is 4. Negative 6 plus 4 is negative 2. 4 times negative 2 is negative 8. 5 minus 8 is negative 3. 4 times negative 3 is negative 12. And looky there, we ended up with a remainder of 0. And so therefore, our answer is k equals 5. And that is the value that would make x minus 4 a factor of this polynomial. I would like you guys to please go ahead and try this idea on your own as well and be ready to discuss it for the next time that I see you. That is the end of this lesson. If you guys have any questions over anything I talked about, please feel free to email me. Otherwise, I hope you have a wonderful day.